Hello and welcome. I'm Bill Wake. We're here working on a program to compare tunes for similarity. And the thing we're working on now is clustering. We're trying to say, here's some tunes, we've estimated the distance between them, and we want to group them in ways that reveal which ones belong together. And we spent, I don't know, probably an hour or so yesterday looking through different alternative algorithms and stuff, and we finally settled on single linkage agglomerative clustering, which sounds pretty fancy, and we'll see how it goes. All right. Well, at the end of the day yesterday, we left off running tests, and we have one failing test in our new proximity matrix. Okay, so this thing is a data structure that's going to hold the clusters as we're building them and tell how far apart each cluster is from the other clusters. What this test got us going on, though, was this distance notion, and our Parsons code tells us what it calls similarity, 0 to 1, which I interpret weakly as kind of the probability that they're the same. It's not really a probability, but it's a function. What I want to do instead, I'm going to disable this one, and let's go back. We said we would do this. Well, maybe I didn't put it in here. We want to make sure that, oh yeah, here we go. Distance instead of similarity. Let me turn this on. Okay. And let's just phrase that positively. Use distance instead of similarity. Okay, so we'll open Parsons code and its tests. Okay. Oh, I guess the wrong one. That's okay. Down at the bottom, we have this notion of similarity of equal tunes. I want this to become distance. And it's not a true distance. It's just some sort of conceptual distance, but that's okay. It's 0. So let's make this thing be 0. And I'm going to do that to all of these. Well, I'm going to subtract 1. So a half won't matter, but this one will become a 1. Well, let's fix the names. So distance between partially divergent tunes is 1/2. Distance between totally divergent tunes is 1. And distance of tune versus fragment is scaled by matching length. Okay. Well, what this is, it's not going to become 0.75. All right, those several tests should all fail. Yep, good. Okay, and then in the end, we're just going to take the difference from 1. Okay, so it's a score 0 to 1 with distance, 1 is sort of arbitrarily far away and 0 is right next to each other. That should all pass. Oops. What I did there. Okay. So good. Let's capture that. So make Parsons code report a distance metric rather than a similarity. And let's also fix that name. Parsons code similarity. Let's make it distance. I don't know if I can use the word to. Can I? It's going to break everybody. A compiler. Huh. Okay. Alrighty, let's go back to our proximity matrix test. And I don't know, we were just starting doing this thing, and I'm kind of struggling to find the right starter test. This matrix has a bunch of clusters that each have a sequence number. And we're trying to say, I want to get the distance from some object to some other one. And now this one, I've got it on proximity matrix, but it's really kind of an arbitrary thing. I don't know if this is the right test or not. Let's re-enable it. I guess we're going to go back to our reference here. I think I've searched hierarchical clustering. Gets us in the neighborhood. We want the bottom up. Nope. Single linkage clustering. This is the page we're working from. All right. So this priority matrix, let's see. So that's this D. The n by n proximity matrix D contains all distances. The clusterings are assigned sequence numbers and levels. Cluster with sequence M is denoted M. Okay, so one thing we know we do is we add a cluster to the matrix. Okay, so I think I want to start there. Let's not do this distance thing. I don't think it's wrong per se, but I just think we're not quite ready for it. Let cluster equal cluster. Well, yeah, we knew this was off too, so here we are. And let's add an element. Cluster dot element 3. Okay, we're generic over it, so it doesn't matter what we use for our tests. And I want to say matrix dot count equals 1. All right, well that'll give us something. There is no count. All right, so public var count of int return 0. All right, let's fix this name too. Adds cluster. Okay. So somehow, right. So this matrix is n by n. Let's see. It contains distances, and they're organized by sequence numbers. Now the sequence numbers will not come in order. Let's go down here. So A, B, C, D, E, let's call it sequence, 0, 1, 2, 3, 4. Okay. They're all there to start with, but then we combine A and B, and the sequence number is now 5, we get a new sequence number. We would add, I don't know, we could add it to the bottom or the top of the thing. That's fine. We also don't need a fully symmetric, the matrix is symmetric, so we can just get by with the bottom half. All right. So I think you need to add a cluster with a sequence number. All right. Let's assume our matrix is going to be an array of these things ordered by sequence number, ordered by increasing sequence number, and each array entry is going to contain a distance score. Okay, and so I think we'll keep an array of some sort of cluster and a list of scores. We don't really need the list of scores yet. Let's just start with the cluster. Okay. I'll say matrix is array of cluster. That'll get us started. Okay, start's empty. Okay. And yeah, we need a generic. Needed hashable. And this is cluster of element. Okay. And then, oh, well, we didn't do a matrix.add. Huh. Okay. Add cluster of element. Well, actually, it's a cluster. Okay, this was 0. Should still fail, but we're close. Oh. Yes, I do. An unexpected second identifier. Okay, now we can do the answer. Return matrix.count. Okay, so start creating add and count on priority matrix. Now, we started putting together a cluster yesterday. And the fact is, whether it's an element cluster or a cluster of other clusters, it needs sequence number and level. So I need them on here too, which makes me want to add them. I don't think you can, but it makes me want to add them to the enum. And I don't think that's legal Swift. Add field to enum. Yeah. You can add functions. I don't. Well, we'll see what we get here. This. Okay. I know I've seen this tutorial before, and he's going to say we can add stuff to it and we can iterate over it. Associated values. I mean, I can associate them to the same thing, and maybe that's okay. Yeah, that's all interesting, but not helpful. All right. Yeah, so the problem is these need to be on this case too. Now, the easiest way is probably just to add them to both. The problem becomes then to find them, you have to separately pull them out, which is doable but annoying. The other way we started to sketch out yesterday is to make cluster a struct with these elements with sequence number level and the, I don't know what we call it, children maybe. So that looks something like this. Struct cluster, let's call it cluster 2, but it's probably the real cluster. And we're going to give it sequence number and level. I mean, I sketched out almost exactly this yesterday. Var sequence number of sequence number and var level of level. And then we have to do children is a cluster. And maybe this is back and forth a little bit, but it changes this from, it takes these out of here. Okay, kind of like that. Requires arguments. Yeah, it's going to have to be. Okay, so I think we can refactor to something more like that. Most of our code doesn't care. Okay. Okay, let's make this generic. Okay. That's fine. Okay. Now set the cluster of E. I think it's that. Hey, welcome back. Can you use a cluster for the single element? Well, we are now. So the problem is, let me put those back. I need these even for the single element cluster, and so I'm trying to figure out where the best place to pull out this commonality here. This E is really going to be like a tune number or something like that. It's in a totally separate domain. But clusters have clusters in them, but every cluster needs these two fields, sequence number and level. I don't know, maybe it's not so terrible, but Maybe, I don't know. Let's do it that way first and see how bad it gets. Okay, so I'm gonna just I think we can call it refactoring still. I don't know. It's a little. We don't do anything with them yet, so that's something, I guess. Okay, so we have that, and we'd have to deal with the callers now. What I'd really like to do is add these two fields that are held by every instance of my enum into the enum here. It would be very natural for me to do that. All right, so let's fix the call sites. Everybody's going to have a sequence number and a level. Right now, nobody cares what they are. It should be tests. I think only tests care. Yeah. Okay, so I have to give it a sequence number and a level to create an element. And we'll do that here. Sequence 1. Oh, that can be 0 still. This one should be 1. Okay. And that, and then here. Okay, so these should all work. Okay. I'm maybe working from the wrong end here. All right. Now I want to be able to ask what the sequence number of a cluster is and what its level is. So let's put some tests in for that. Well, this setup is actually pretty good. Okay, cluster knows sequence number and level. Okay, we'll just do them both in one thing. I'll make these different, and those are different. Okay, so if I ask C1 dot sequence number, I expect 0 out. Whoops. Let's make them the same, just the same as their name, so we can keep track of them a little easier. C1 dot level should be 0.0. C2's level, whoops. Level is 0.5 and level is 0.75. All right. These functions don't exist. Okay. And now the problem is, to get this out, I have to decode, are you an element or a cluster? So it's very, I don't know, feels off to me. Let's see, one is C3. Oh, yes, thank you. Thanks very much. Okay, so sequence number, if it's an element, it's got a sequence number in it, and then we don't care about these two. Well, I'll just return 0. I guess I'm jumping ahead a little bit. Okay, each case returns 0 and level. Oops. Okay, now can we build? Yeah, these tests should fail. Everything comes back 0 for those and 3 for these. All right. So sequence number will return sequence number. Oops. So you can see why I dislike this. It feels very redundant to me to have to pull the same field out, and I can't make this part generic. Like I don't care which element it is, pull out the sequence number kind of thing. I can't do that. I've got a switch on it. So that's the kind of duplication putting it in a struct would do. But then I've got to deal with 2 levels and all the crap that goes with that. So there's no great solution, I don't think. Okay, now this sequence number is nothing but level. Okay. All right, so add sequence number. Oh, you're right, we can at least do that. And level to cluster. Oh, I don't think it works in this case though. We'll see, but I got a feeling it's let's see, try it. Let's see, you don't do it like this. This is a comma, you don't have the case. I don't think it'll let you do this because they're not structurally compatible, but I may be wrong. It's not complaining yet. Oh, good. Okay, yeah, let's fix that. That helps a little. I'm still annoyed with it, but it helps. Okay, and here, thank you. I thought I tried this and it had given me grief. I don't know, maybe it was something I tried a year ago and they've updated it to let you do this since then, but that's okay. We'll take it. All right. Use fall through. Well, it's not really fall through. You can actually say fall through instead of break, but just use common or use list of cases for sequence number and level. Okay. Right. Now, I'm going to go back to proximity matrix. We're still just holding clusters, and that's okay. We know we can remove a cluster too. Let's do that. Okay, so we'll create the matrix, put a cluster element in with 4, matrix add, we know the count is 1. We could still think of that as a check to make sure, but let's matrix.remove. I think we just want to give it the sequence number. Okay, fall through a little different from the yeah. I think it's because of they made it so it automatically breaks at the end of a block of each, at the end of each case. It has an implicit break unless you put the fall through in, and because there were a number of, even since that structure comes from C, and even there they had a lot of problems where they would forget to put the break statement in and it would fall through and cause havoc. All right, so we're going to add a remove function based on the sequence number now. Okay, so I think that's good. Function remove, and we're giving a sequence number. Okay, and then I know there's a function for this. Remove. Is that it? Remove all. Well, okay, yeah. So remove where the item dot sequence number equals sequence number. I think should do it. Oh. Remove all. Okay, but I didn't run my test yet. Let's make it fail. For the right reason? Okay, came back 1. Good. All right. Remove all. Okay. Yeah. It's just sort of an in place. I could filter it and reassign it, but it kind of does it in place. All right, so we can add, remove, and count. I guess I'll move this down. Those go together more. All right, let's see what else we got to do. We're getting to the point of the real thing here. Okay. Well, it's such. Oh boy. It becomes so involved. I just dread testing it. But we also have this function D, and well, they're saying it D. Let's see, did we define it up here? We didn't really define it. D is it, these for anything in the original set. There's a distance function. So that's what came out of our parsons code. Okay. So we would like to have D of our matrix as well, and it's going to be based on this distance thing. And I think the thing is, you really need that D function defined for our parsons codes. I almost want a separate little permanent matrix, because asking this capital D, X and Y are both clusters. So they are things that contain a bunch of elements. You're saying, given this list of elements versus that list of elements, which one is the closest? Well, it'd be nice to just have those pre-computed, ready to go. Now, maybe I don't need to pre-compute them, and that's fine. It could be responsible to cache it or whatever, but maybe we can skip that pre-computing part for now and just define this. Okay, so we got to run through pairwise everything, which is why this thing is order n cubed is expensive. Now we might be able to devise something. I don't know. I bet we can devise something faster, that's more incremental. Like when I add some element to X, I need to add X versus each element in Y, but somehow that should, I don't know. I feel like it should be possible to get something faster, but all right. So dxy, this is the thing we can't calculate yet. I'd like to know, given D, what are the minimum distances of its clusters? And yowza. Okay. Is there anything else we can do with D first? It's got distances. Update D by deleting R and S. Okay, we can do that. Adding a row column for the new one. Yep. And define its distance. Okay. All right. Well, maybe that's helpful. Okay. So let's start with two simple elements, I guess. I think we're to the hard part now. We want to ask the cluster ask the matrix a distance between two of its cluster elements. Okay. And okay. So let's start here. All right, we certainly need a matrix. Okay. We're going to add a cluster. Well, how about distance from cluster to itself is 0? All right, so let's add the cluster. And we can say assert equal matrix dot distance from, I think we want to ask the sequence number. 4 to 4 should be 0.0. Okay. Right. Distance. This is a sequence number. Let's say two other is sequence number, and it returns double being the distance. Okay, and for starters, we'll make that return -3. Test should fail. Not quite what I was looking for. Oops. Put that in the wrong place. Well, I almost think this reads better. Good. It gets -3 instead of 4. Yes. Okay. Right. So, okay, this is where we got to start working. All right. Well, I guess we can take that branch off the top. We know the diagonal is always 0. Okay, so if sequence number equals other, return 0. Yeah. Okay, I don't know. I'm pushing off the hard moment here, I think. Is that helping? Well, I think it's a true statement. So I've got cluster 1, cluster 2. Oh. Wait a minute. Matrix distance. Oh, this one. I didn't put the cluster in the matrix. So if it's not there, I'm just going to I'm not going to worry about it. Make sure that's not going to affect it. Maybe when I create the matrix function, I've got to give it a distance function, an element distance. Because how's it going to know the distance? I think I want to say it's 2 in this case, just taking these ints because really these elements are going to be like tunes for us. Or, yeah, probably tunes, maybe Parsons code, but probably tunes. And I need a function that compares them. But here I'm just using ints. I should be passing in a function. Um, hmm. So I'm imagining a function that takes the element type and well, it's got to take two elements. Okay. If I pass in a function of two elements and it returns, what does it return? It should return a distance. Let's start using that word here. Okay, so now I'm saying there should be an init. Init, and it's going to take an E1 of element, E2 of element returns distance. I'm not sure I'm writing that declaration right. And is that? I don't need E1 and E2 then. Okay. Right. And then everybody needs it. Good move. Good. Okay. Well, I'm going to make it. I'm going to make it. I may regret this. I'm going to not do that. All right. Let's just make it element distance. This is E1 of int, E2 of int returns distance, and we'll take this. Okay. Now all this, I'm still trying to get my test that fails, but Okay. Now, again, this is somewhat coming from trying to keep this thing generic over the types, because it does make this testing easier. -3 is not equal to 2.0. Okay, so where's that -3? That's this thing. All right. So now, test case should only contain private. Okay, fine. What else do we have? Okay. All right. So I need to store this function. Okay, so I've got the function, and then I need to use it. Huh. Okay. All right, I think we have the pieces. Test case should only contain private, non-test members. Okay, I think that's an old message. All right. I'm always forgetting to put escaping. Okay. Well, this will fail the same way. I'll get rid of some warnings. I think I have to implement this whole function regardless now. Okay. That feels like a big enough step. I think what we'll do, let's just take a quick break. We've got the failing test. We'll know where to pick up when we get back. But I think basically I've got to walk through the elements and calculate their minimums according to this rule. Now, we can do it better later. This looks like a better rule, I think, but it's the same in effect. This is more incremental in computing it. Okay, so we will take a break and come back and tackle that. So 3 or 4 minutes. Excuse me, 3 or 4 minutes. All right, welcome back. Okay, so calculating this, I think we want to take, it's kind of like an all pairs thing. We want every x paired with every y, and then apply our distance function and find the minimum. All right, and then later on we'll come back and do the optimization. Yeah. All right, now I feel like I think Swift algorithms may have something like this. So let's see. That's a package, like I really should. It would pay to just sit down and study it in a serious way. I kind of read through or I don't know, watched the WWDC videos. Adjacent pairs. Combination permutations, rotate. There it is. Iterate over the pairs equivalent to nested for loops. All pairs of 2 collections. Okay, so product. Okay, so that's equivalent to that. Okay, so product over that with that. Okay. Um, Boy, this is a lot of work for one little thing. I guess if it works though, I should be able to plug in a more complicated case with deeper clusters. Okay, so let's take um well, um we've got to find the clusters of those two sequence numbers. So let's add that. Um okay. And let's find the second one of other. Okay. And then the find, well, again, we're going to take a poor implementation. Maybe it's okay. It's not going to get that big. Matrix dot index of index where. Okay, we don't know the element, so I think index where is going to be the thing. Index where, take the predicate element to bool and returns optional index. Okay. Right. Okay. Guard. What should we do if it doesn't show up? I don't know. In a way, I think it'd be fine to blow up. Okay. Okay, we got the position, and then let's return matrix sub found. Okay. Okay, so given the two clusters, all right, we want to say let elements one equal cluster one dot elements, and elements two and then well, I think we're going to take product of elements one Can we take a min from that? I don't think he's can't find product. Okay. Import algorithms. Dot min where. Well, let's see what this is. Let pairs equal that. I think it should just be a pair of the two elements. Yeah. Not liking it, huh? Let's see if we can get a little explanation. No such module algorithms. Okay. I can see that would cause a problem. No, I thought I had it listed as a dependency already. No. Huh. All right. Dependencies. Okay. And no such module algorithms. Maybe I have to add it here too. And I'll have to do that. I think I'll have to do it on my main one when I move it back over. Unfortunately, but okay. Come on. Oh, did it fail for the right reason? Is that message? Import should be sorted. Really? You want it above the testable too, huh? All right. What the heck? Okay, I think I'm getting something conflated here. No, still. Product. Is it base one, where base one is a sequence and base two is a collection? Okay. Well, I assume that's saying it's a collection. And you'd think it'd be a sequence. Yeah, it should be both. Okay, we don't care about that. Product sequence. I can't tell if it's not finding it. Let's try. I know this thing's not going to like it. The top product. I think the cross product. Yeah, we want the pairs of all possible values from element 1 versus element 2. Okay. Oh no, it's still failing. Oh. All right. He's got algorithms as a dependency. And the project has it as a package. Where's my console? Well, that's not helping. I don't remember where this thing. Okay. Let's take an example right from here. I don't care about those things. Let's take this out. Okay. I mean, S10 algorithm 7, whatever, sounds like it knows it's got that package, but it just can't. Okay, let me clean again. Unless it's producing that. Huh. It just has so many, it makes me think it must be there. Command field. Where is that in the console? All right. Go back here. I've got it in the project. Okay, there's Swift algorithms. So he shows up as a package dependency. All right. So he is there. Shared tests use him as a target dependency. Do I have to put it here too? Maybe I just left it out. I thought Target would put it there. Yeah, there it went. Okay, so that thing worked. All right. I obviously don't include other things enough. Okay, so this should compile. Yes. And then let's get back to what we're doing. Okay. This compiled. Okay, cool. All right, so now I have elements 1, elements 2, pairs of each. All right, so I want to do pairs dot min. I need min by or an increasing order. Yeah, that's the one I want. I want to give it a function. Okay. And now I got to call my function up here. Oh no, that's not going to work. Okay. Sorry, that was like min by increasing order. Hashable. Okay, what's the type of this? Element. Okay, I'm hoping we get pairs of elements. All right, let's check that. Pairs dot for each. Okay, so E1 should be an element, E2 should be an element. Okay. So I'm going to do pairs.min by using the given predicate as comparison between elements. Okay. Or an increasing order. Okay, element goes to bool. So true if it's less. All right. So now, I've got two elements. I want to call element distance. Well, why am I not comparing distances? Okay, he's going to give me two elements. I want to know which one is less. I don't think I want to do that. I think I want to do a map. Okay, if I map them, let's do it this way. Map them to E1, E2 in. I want to apply my distance function, element distance E1, E2. Okay. Now I have a list of distances and I want the min. Okay. And then okay. Min distance equals that dot map dot that return min distance bang. Okay. All right. So I'm taking all the elements in 1, all the elements in 2, applying their distance function, finding the minimum distance there, and that I will always have at least one element in each of these. So this will always, this product will always have at least one element. So this map will produce at least one element. So min is always valid. Hate to argue my way in that, but think that's right. Okay. Does that work? I don't know. It's more than that test deserves, probably. Okay. Let's see. Add distance calculation to priority matrix. And gosh, all this stuff is being done rather inefficiently, but okay. So I think making this answer, it had to go through the elements in the cluster no matter what. So I think that's okay, but let's do this. Okay. So distance from one element to another is, well, that's not really what that test is testing. That's sort of true. Okay, so now I'm going to make a cluster. I'm going to make a cluster with 1 and 2, and then a cluster with 3 and 4. 3, 4, and then let cluster 1, 2 is cluster dot cluster sequence number 5. Level 1.0, don't matter. And cluster 1, cluster 2. Okay. Then cluster 3, 4 is cluster 6 is cluster 3 and 4. Okay. So I've got 3, 5. Let's make this like 10, 11. Okay. Those two are relatively close to each other. Each little cluster is relatively close. And then the bigger cluster captures both the inner ones. And then when we diff them, the minimum distance, okay, so we got 3 versus 10 and 11. The smallest distance is 7. 5 versus 10 and 11, the smallest distance is 5. So the overall distance ought to be 5. And we're going to add cluster 1, 2 and cluster 3, 4. And this is element 5 and 6. Let's maybe make them, let's do 10 and 20. I just want to make sure my 5s don't get mixed up. From 20 to, well, from 10 to 20. And then I don't mind asserting symmetry. 20 to 10. Okay. My expectation is this passes, that minimum distance is the maximum of 2 versus the minimum of 3, 4. And I think my argument is kind of the same as this. Take the minimum. No. We'll cluster K. Okay. Well, I guess I'm not. I'm saying well, no, I can intersperse these and make it interesting, right? Let's do that. 1, 4. Okay, so 1, 3, 3 to 1, the distance is 2. 5 to 1, it's 4. 5 to 1 is 5. 3 to 4 is 1, and 5 to 4 is 1. Okay, so the minimum distance ought to be 1. Maybe I'll make this 6 just to kind of enforce it. 3 versus 1 is 2. 6 versus 1 is 5. So of those two, 2 is better. 3, 1 is 2. 3, 4 is 1. 6, 1 is 5. 6, 4 is 2. So the 3, 4 should be the closest and should get a 1 back. Okay, let's make sure this works. Yay. Okay. So check distance with a more complicated cluster. Okay. Well, that feels like an accomplishment. Okay, so the fact is we should be calculating those once and dealing with it, and instead we're looking up distance every time they access it. So that really is a slow way to do it. But I think, okay, now are we ready? Okay, well, we're not quite ready. Well, I think we could do this with integers in our examples and probably be okay. Okay, a pair RS is DRS equals min of DIJ, where minimum is overall clusters. That's kind of what we did for just now in step 2. Okay, merge RS, set the level. Okay. Update the matrix by deleting rows and columns. Okay, we have not done that because we don't really store those calculations, right? So we're recalculating dxy every time. So all you got to do is delete the row and column and everything's hunky-dory. Okay. Okay. Well, how can we test this thing? Well, the result is a cluster. All right. So let's see. So I think what we're saying is the result is a single cluster which contains other clusters. And So I'm envisioning a test that's just sort of a linear sequence of numbers, like 1, 2, 3 are a big cluster, and then skip, and then go to like 10, 11, 12. That should be a cluster. And if you skip to 50, that should be a new cluster. And then the next stage should pull the first two together, and maybe the third one. I don't know. Let's design something that will have multiple levels. We don't yet compare clusters. Okay. Maybe this is different. Minimum pair of clusters in the current clustering. Yeah, I don't think we exactly do that because we don't, like, somewhere that should mean iterating over every cluster versus every other cluster. Well, let's go back to algorithms because nope. I don't know where we did that. We definitely saw something that should do that. Well, combinations. Right, if you ask for all combinations of size 2, that gives you every pair. Although we really don't want we don't want A, B, and B, A. We just want one or the other. Genie cycle joined. I don't think we get an easy way to do that. Now, in a sense, it doesn't matter. But I think in our algorithm, we need to find what R and S are. Okay. We don't give you enough information in our matrix to do this yet. All right, we could. Well, I mean, really, what we want to ask for is the pair of indexes, sequence numbers, with the minimum value in the table. So I think we have to go from 0 to n minus 1, A, B, C, D. So we're going to go A, B, A, C, A, D, A, E. B with C, B with D with E, D with E. So we need N. Well, okay. We need N minus one of these and N minus one of these starting at the second one. Okay, to get all pairs. I don't want all pairs. I mean, I guess I could filter them. How did I lose that? There it is. Okay. I mean, I could get all the combinations, filter out the ones where I definitely don't want the combinations where an item is less than or equal to itself. So I want I want AB, not AA, or actually I start at B. I want BC. I don't want BB because it's equal to itself, and I don't want BA because it's less. Okay, so we can do it with combinations. All right. So what are we trying to do? We're trying to get the minimum cluster, minimum pair. And actually, if I remember this example, it's minimum pairs because AB with C and AB with E are the same. Okay. All right, but let's start with the minimum pair, and then I guess that just, if we don't do pairs, we'll get multiple clusters that kind of work the same. All right, so given a matrix, I want to walk over everything in it and get the minimum distance. Whew, okay. All right. I want the pair with the minimum distance. Okay. We'll take this as a starting point. And we'll let cluster 5 equal cluster dot element 50. No, yeah. 5, 4.0. We don't care about the lengths yet. And 50. Okay, so 3, 6, and 1, 4. Oh, let's make this 7. Okay, so this is 4 apart. This is 3 apart. Maybe I shouldn't do these clusters just yet. Okay, so if I do these, I've got element 3, 7, 1, 4, 50. Okay, I would expect 1 and 3 to cluster. No, 3 and 4 to cluster first. Then 1, 3, 4. Okay. And 50 is an outlier. Okay, so I'm going to add all these. Well, let's just let clusters equal this. Clusters. Okay, and then clusters dot for each. I want to do matrix dot add $0. Maybe I can make it a better. Let's see. So the distance, I'm looking for the distance between cluster 1 and cluster 2. I have to do pairwise on each one of these. So 3 versus 1, distance is 2. 3 versus 4, distance is 1. 6 versus 1, it's 5. 6 versus 4, it's 2. So the one we had a 1, 2, 1, 5, 2, or something like that. But the 1 was the best. So that's the distance we got for the clusters. Okay, so we're only putting the clusters in the matrix, the big clusters, not the element by element ones. Okay, so I hope it makes sense. It's getting complicated though, I'll grant. Okay, so I'm going to add each cluster into the thing. So now I just have 3, 7, 1, 4, 50. And if I ask the matrix, let E1, E2 supposed to be the best pair equals matrix dot best pair. I think that's that. We're defining the interface. And then I'm going to assert equal set of if I do a set of E1, E2, that should be the indexes of the two closest items, which are 3, which is element 1, and 4, which is element 4. Okay. And I'm leaning on this thing pretty hard, I guess. But I think that's saying this step, find the most similar pair of clusters. The matrix has all the information, and it's going to return the indexes of the two clusters. Maybe I want the clusters. I guess I do, right? Okay. I guess I want this to be the clusters. I'm adding cluster elements and I'm getting the best. I should get C1, C2, and this is sequence number. Okay. Okay, so I want to find the two sequence numbers that give me the closest answer of any of these pairs of values. 3 and 4 are it. Okay. And let's go to matrix best pair. It's going across everything, so that's fine. So it's going to be back a pair of cluster. Okay. It's an element. Sure enough. Okay, now, so we want to run through all combinations in the table where the second of the pair is its sequence number is greater than itself. So if I'm on B, I only want C, D, and E. Okay, so I think, well, let's return, well, we'll just grab matrix of 0. This is a very bad answer. Okay. Should fail if that's not clear. All right. And it returns 0, 1. Oh, I put them in a set. Okay. 1, 1, 1 was what it returned because that's the first element. And then not equal to 1, 4. Okay. Good enough. Oh, you want that last comma, huh? Okay. Good. All right. So we want to take let sequence numbers equal, let's take the matrix dot map to sequence number. Okay, so now I have the numbers of the clusters. And then I want to take combinations. Combinations of count. Sequence numbers dot combinations of count 2. Okay. And then I want to go filter. It's a pair, and I want to include it if pair sub 0 is less than pair sub 1. Okay, so I've got the sequence numbers 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, 1, 2, 1, 3. Okay, so if I have 1, if I get 1, 0 coming in, I don't want 1, 0 because the second one is less than the first, rather than the first being less than the second. 1, 1 still doesn't qualify. It's not less than itself. Okay, so I think that gives me the indexes of all the things I have to compare. And now we've got our distance from those two. Okay. Do I have enough to drive this? I think I do. Okay, so I've got a pair of sequence numbers. I want to find the best. Let's try best pair equals -1, -1. Okay. And all right. So I've got those sequence numbers, and I want to say for each pair. All right. I want to decide if those sequence numbers, sequence number 1, sequence number 2, in, okay, and how about best distance? Least distance. Well, let's make it 1 to start with, since we range 0 to 1. Okay, I think I can do it. So I've got every pair of sequence numbers, and I want to decide if the distance from sequence number 1 to sequence number 2, I guess let new distance is that. Okay, so I know the distance for the new pair. If new distance is less than least distance, then I found a better match. And so I want to say best pair now equals sequence number 1 and sequence number 2. And I want to say that the best distance, the least distance, is now new distance. Okay, so I believe when I get out of this loop, well, something's wrong. This makes one argument, but 2 were used. Oh, okay. We're going to come back around, I promise. All right. It's giving us a pair, an array of pair 0 and pair 1. Okay. All right. If calculate the distance for these two new numbers, if it's less, so when I get here, I've got the best pair and the best distance. All right. I don't actually care about the least distance. Best pair was never written to. Oh, never read. Okay. Yeah, because my return value, I need to return matrix dot find sequence number best pair dot 0 with best pair dot 1. Cluster has no element to find. The pair are these sequence numbers? They must be, or this wouldn't work, right? Yeah. Okay, where's my find? Oh, I don't need to say matrix. I got to say just find. Okay, and what am I returning? A pair of clusters. Prefer implicit returns. I don't know what that means. The for each ended here. Prefer implicit returns in closures, functions, and getters. I don't know what that means. Well, I don't think that would work here. Let's build again. Okay. Fair, but not the real problem. Found nil while unwrapping optional value. Okay, let's go back to the tests. Okay, I guess I want to find out. It looks like these tests are okay. So it is this test, as we'd expect. If anything had a problem, it should be the last one. Okay, so what is this sequence number? -1. Well, no, we don't want to do that. Okay, let's stop here and see the sequence numbers. No values. Okay. Oh, who's matrix? No, that's fine. All right. Did I forget to add them? Sure enough. No, I didn't. Matrix.add. Okay. So when I get here, the count should be 5. All right, let's make sure that's true. Oh, I didn't step over. Ding dong. I'm puzzled. Okay, sequence numbers is 1, 2, 3, 4, 5. That's what I'd expect. Best pair is sequence numbers -1, 1. Okay, that's fine. All right. Let's print sequence numbers dot combinations of count 2. Oh, it's not going to do it, is it? Two less than 3. Okay, sure. 2 is the only number less than 3. Let's put it in an array. Oh, how many times do I do that? Okay, cool. That looks promising. 1, 2, 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5, 3, 4, 3, 5, 4, 5. Okay. Those are the values we want. Oh, we don't need this filter then. Okay, but let's continue. One versus two, the new distance. New distance is 4. Oh gosh, I should be using a lot bigger number than 1. Okay, that's a flaw in the test. Well, maybe it's a flaw in this. Right, this 1, let's do double dot max. Double dot. It's not max. Sure, whatever. Okay. The least distance starts out at more or less infinity. And let's just run, clean out some of these breakpoints. Continue. Okay. Okay, the good news is it's working the way I want it to work. Okay, I think that helps that. All right. Let's go back here. Close out some of these. Okay, this is our single clustering. All right, level 0 equals 0. Well, we're keeping the level. Okay, level is distance of RS. Okay, so we need a sequence number. The clusterings are assigned 0 to n minus 1. Okay, so I think step one, we've got to put all our individual numbers in with level 0, and well, sequence number is going to increase as they get installed, I think. Okay, and then we're going to find the most, okay, this goes back to step 2. So it's really a while the table count is greater than 1. Keep going. Okay. Wow. I guess if I put one element in with sequence number 0 and stopped because there was only one element, that would be something. Oh boy. All right. Test. One element matrix terminates, clustering terminates right away. Immediately. All right. It's probably kind of close to this. Okay, so we're going to create a proximity matrix. We're going to put the cluster in. The M is 0. The distance L is 0 and 3. Okay. And matrix dot add cluster 1. And the whole thing, I guess, is cluster all. Clustered. Okay, and if I ask for let result equals matrix dot clustered, then well, I really should be getting back element 1. So let's make sure result dot sequence number should be 0. Clustered should return a cluster of E of element, and it's going to look like this. Oh, yeah. Okay, we got to start with the disjoint clustering with L0 and sequence number. I think whoever puts them in yeah, I think whoever puts them in is going to have done that. All right, and then we, if the count is 1, just return it. If matrix dot count is 1, return matrix sub 0. Be the only thing left. We haven't dealt with removing very well. No, I guess we have. Okay. Otherwise, we're going to blow up. Okay. Otherwise, we'll still return matrix sub 0. Matrix sub -1. Let's make sure we crash. Okay. Did we see that fail? Not really. Okay. Let's just leave this part out. Okay. This should... Oh, we did make it a function. Okay. Okay. Okay, so now it's working like that. I'm going to say, while matrix.count is greater than 1, do something, otherwise return matrix sub 0. That's not going to be very safe, is it? Okay, I'm not going to do that. Okay, let's push this for a moment. I think we've got multiple things already. Yeah. Okay. So this is minimum distance pairs. Support priority matrix finding minimum distance pairs and start clustering. Okay. All right. Now it gets worse. Okay, so I think we'll have to... Well, we can start with... We could start with 2 pairs. Merge them. Okay. Yeah. Let's make a single pair. Well, let's put 2 elements in, and we should get a pair back. All right. Okay. This has to be 1 distance element. Let's make it 4. Okay, we'll add cluster 1, add cluster 2, and we're going to get the result back. Well, result.sequence number should be 2. And, well, I break this up, it's big enough. Execute assert equal. What can I get from my cluster? Oh, I guess if I knew my elements came back with those two things, I'd be happy. I can't come back with two if I'm one of these. I can only do it if I'm a set. So that would tell me I got the cluster back. All right. Result dot elements dot count. Well, no, a result dot elements should be the set cluster 1, cluster 2. Okay. That's, whoops. Okay. I'm getting the actual elements. That's 3 and 4. Okay, that's a tricky one to keep straight. All right, good. This should probably be coming back with 0. Yep. And this is coming back with 1. Okay, yeah, 3. One value. All right. The clustered. Okay, so now if the matrix count is greater than 1. All right. Well, most cylinder clustering is the pair RS. Okay, so, well, that's what find gives us. Sorry, best pair gives us. Well, what does find give us? Does it give us the cluster? Oh, we do get the clusters back. Okay. Cluster 1, cluster 2 equals best pair. I think we can do it like that. Okay, so now we've got the best pair. Hopefully that works. Okay, yeah. And we're supposed to, well, I guess we need to figure out okay, that's the best pair. We need to get the new sequence number. I guess it's M. If we're going to reference this algorithm, maybe we should, well, I definitely should put a comment in. Okay, this is the algorithm from this, retrieved. Okay. Okay, M is, we're going to go through the matrix, find the element with the biggest sequence number, and add 1. Dot, map, we're going to take each cluster and get its sequence number dot max. Okay, it will exist if the matrix has anything in it. I think we're going to be okay assuming that. All right, plus 1. Okay. Maybe we can do it that way. That's the biggest one currently. Okay. Now we're going to increment M. Okay. We're going to merge clusters to the distance. Well, that is this. Okay, another optimization. All right. We're going to make a new cluster. New cluster equals cluster dot dot cluster. The sequence number is M. The level is, well, it's this distance. Distance from cluster 1 dot sequence number to cluster 2 dot sequence number. I guess that's there. And it's going to be the set cluster 1, cluster 2. Okay, and let's call this distance. Okay. That's the new cluster. Merge them, set the level to distance. Okay. Update the matrix by deleting the rows corresponding to R and S. Okay. Matrix dot remove sequence number. And then we're going to add. Okay. We're going to add the new cluster. Sorry, these are not matrix, they're local methods. Okay, proximity, and then continue. Radius label at. Okay. I think that's it. It's supposed to pass now. All right. Feeling good here. Okay, so I think our algorithm is basically done. I think the next step is to write a test, and then we got some thinking to do, what we want to do about it. I don't know. It might be nice to just add the elements, add the actual elements, and let this matrix worry about the values there. Okay, but we're not going to worry about it. We're going to make a new test. And I'm just going to sketch it out, right? We only have a minute or two. All right, so let's see. Clustering many items. Okay, and let's do like we did with the loop before. Well, let's make some values that are a bunch of ints, and then we're going to let the clusters equal something, and they have to do the seek number in order, level equals 0. Okay. And then we're going to do clusters dot for each matrix dot add cluster $0. Okay. And then the result is matrix dot clustered. And that's going to be something else. Okay. So what I want to do is make some obvious clusters, like I mentioned before, 2, 3, 10, 11, 12, 50, 60, 61. How would that be? So I would expect these 3 to cluster right away, these 3 to cluster right away, these 2 to cluster right away, these 2 groups to cluster together, these 2 to cluster together, and then the whole thing to do that. Okay. We might develop a little print method for our clusters. Some recursive print or something. Maybe it can put those sets of items in nested lists or something, and then we'll just print it. Okay. Cluster set add $0. Okay. Yeah. Let's stop there. All right. So we've got somewhere to pick up tomorrow. Tomorrow it's 2 to 4:30 p.m. Eastern time and 6 to 8:30 p.m. UTC. I think I have an appointment tomorrow that I have to leave a little early. But whatever it is, we'll have an hour or so anyway. All right. Yeah, this was complex. Gosh, I mean, it's not a horrible algorithm as they go, but we definitely have a couple methods that are on the big side, and that distance between 2 clusters, that's kind of messy. And then this best pair, it's just big enough to be a little confusing, I think. And this one actually I don't think is quite so bad. It makes sense to me. We're always picking 2, we're throwing them out, kicking them out, and then we're adding a new one. So we always go from, we always end up with 1 fewer. So the loop will terminate. So that part's good. But, we got 3 methods that are each, 15, 20 lines and complicated enough. I do think we can clean them up This one maybe not so much, but the others, I think we can reduce them down. And maybe this can go away too, this distance calculation. So it'll get better. But so far we've been working with just elements that are integers. We haven't tried to integrate tunes or any of that stuff in. I think if we get the algorithm working completely with integers, I'll trust it a lot more with the tunes, and we'll see where it goes. But I think tomorrow we'll wrap up the clustering per se. We haven't tried to do the dendrogram piece, this stuff down here. That would be kind of a final display. Knowing that was right would be kind of encouraging too, though. But anyway, we'll pick up there tomorrow and see how it goes. I anticipate, well, we're certainly going to be going into next week to get the drawing and hook it up to tunes and all that stuff. But so far, I'm happy. We haven't really gotten stuck in a bad way. And I do like the algorithm that it clearly removes 2 and adds 1. So it's clearly going to terminate, which is a nice thing in a thing like this, So we'll see how it is. Thanks for joining again and for your help along the way. Take care. Bye-bye.